Today's topic is Identify Cloud Workload. Today's speaker is Dennis from CyberArk. Dennis has been in industry from past 30 years. He is Senior Solution Engineer with CyberArk currently. With that, Dennis, take it away. Thank you.
So everybody wants to a secure DevOps workflow, but the sort of the balance that we need to strike is one between velocity on the one hand and ensuring that we're secure on the other. So today we're going to sort of talk about a couple of solutions or approaches that allow us to enable developers and our people in DevOps to easily consume secrets, while at the same time empowering our security teams to have line of sight to risk, leverage a single platform for credential management and audit, and basically enable them to instill GRC or governance. Okay. There are a number of solutions on the market today that allow us to store secrets. So for example, if I'm working solely in an AWS environment, AWS Secrets Manager is a fantastic way to store secrets, rotate those secrets that we need to do the work in our DevOps pipelines or in our workloads in the cloud for certain AWS offered services. But as soon as we need to extend the reach of our DevOps pipeline or extend our estate to include other cloud service providers such as Azure or Google, or we want to use parts of the estate that we have on premise still, we really sort of get beyond the scope of being able to use Secrets Manager or Azure Key Vault or the Vault in Ansible, for example. We need something that encompasses the entire estate and spans the entire estate. So that brings us to, how do we identify workloads that are running in various cloud service providers and still have a chain of trust and authenticate all requests? I.e., how do we govern access to these secrets that are being consumed in various workloads across different cloud service providers? And the idea here is that if it can be identified, then we can manage its access. Let's talk a little bit about how do we establish and authenticate identity. The first case that is very familiar to all of us is username and password, right? That's typically how humans have identified themselves for authentication for years and years and years. Of course, this is subject to, social engineering. While we have built-in vaults, which is our memory, we can be phished or we can forget those passwords. We can write them on Post-it notes, so on and so forth. So credential-based authentication is something that has been used for years and years, but what it presents to us in these automated workflows or in these ephemeral environments is a need to store a credential to retrieve a credential. And so therefore we have to manage that credential. And that is not something that promotes the velocity that we need in our ephemeral environments or in our CI/CD pipelines. So then we move to sort of attribute-based identities, okay? And when we say things like attribute-based, we're referring to things like perhaps an MD5 hash or a SHA-256 hash of an executable, the OS user or the path. That's great, but it requires an agent to be running in the local environment on the local host, and that doesn't scale to container use cases. Then we start to look at the concepts of sort of bootstrapped identities. Bootstrapped identities are ideal for container orchestration. They're ideal for autoscale groups of VMs, for example, but they are platform dependent and they're hard to implement for legacy technologies. What I'd like to do today is kind of give everybody a peek into what is already available to us in the various cloud service providers, okay? And in particular, we're going to look at Azure and AWS. So AWS, for example, in this top picture here, provides the identity metadata service. And from the identity metadata service, which is available on EC2 instances, information from this is available when we execute Lambda functions and even Fargate. It gives us information that is unique to that particular workload. And we can use the information that we obtain from this metadata service to authenticate workloads in AWS. Likewise, in Azure, the identity metadata service will return to us an OAuth token that we can use to process the claims within the token. We can also verify the signature, and we can use that for authentication. So for the purposes of demonstration today, we're going to be using an open source project that is sponsored by CyberArk called Conjur. Conjur is a platform that allows us to securely store secrets that these workloads need to get their work done. So we encrypt and vault those secrets, and then we provide, it provides various methods of authentication to identify the workload and enforce policy on entitlements. The way that Conjur works is that the requester authenticates to Conjur. Where we're really going to focus today is on 3 different authentication methods that Conjur employs. Those 3 are unique to AWS, Azure, and then we'll be talking about Kubernetes. Once authentication has been successful, then Conjur returns an access token. Then the requester can use the access token to retrieve secrets and access the targets that the workload needs to do to get its work done. So let's go take a look at Azure. So in Azure, we can use a managed identity to authenticate via Conjur. Step 1 here you see is that out of band, we establish policy. We establish what the identity requirements are for the workload. Step 2 in this diagram is that the requester retrieves the Java Web Token, or the JOT, from the Azure Identity Metadata Service and presents that to Conjur. Conjur then takes that JOT and verifies it with the Azure Identity Service. If the Azure Identity Service comes back and says, yes, this is thumbs up, then we are issued an access token, at which time we can then retrieve secrets from Conjur. An identity can consist of just the subscription. So you could say that all entities, all requesting entities within this subscription and in this particular resource group can retrieve secrets from Conjur. We can also add to that system-assigned identities or user-assigned identities. I'm going to show you an example of this using a VM in Azure that we call AZ Tools. Okay, so AZ Tools is just a Linux instance running in Azure, and it is running in the AZ Tools resource group. Okay, and for the purposes of identifying that, we've assigned to it a system-assigned identity, which is this object ID right here. Now, I'd like to make a quick note on Microsoft's recommendations. We often run into this question in the field, which is, we use a lot of service principals in Azure, and why doesn't Conjur use service principals? And that is due to the recommendation from Microsoft to use managed identities, which is basically a representation of an AAD, an Azure Active Directory service principal, that you can use for these ephemeral workloads. okay? So let's go over to AZ Tools. Let's shell over into AZ Tools, and let's take a look at the job at hand, which is to retrieve a secret from Conjur. There's the secret retrieved from Conjur. If we go over and look at Conjur, the Conjur UI, which is actually running in AWS in this particular setup, if we go look at the secret that we retrieved, all right, so the secret that we are trying to retrieve is test variable. Test variable is actually vaulted in an instance of Conjur in AWS. However, we uniquely identified the AZ Tools VM via the Azure Metadata Service and used Conjur to authenticate. And we can see here that Azure Apps fetch the test variable. If we look at the policy that is established, remember we talked about establishing the policy out of band, we can see that the AZ Tools resource group is permitted to retrieve the variable test variable. Let's take a look at this in action. Here are all the steps that we went through to actually authenticate, right? Quite simply, we wanted to retrieve a secret. We retrieved the secret, but we had to go through these steps of first retrieving the OAuth token from the Azure Metadata Service, presenting that to Conjur. Conjur then verified that OAuth token and returned to us an access token. Once we had this access token, which has a very short time to live, we can then retrieve secrets, okay? I'd like to take just a real quick look at one of those tokens that are returned to us. So here's an actual token that was returned to me. I've gone to jwt.io to sort of verify it and look at the different components of the payload. And most importantly, what we can see here is that we were able to verify the signature of that. That's really the first step, is to verify the signature of that OAuth token that is returned to us from the Azure Identity Metadata Service, okay? Microsoft provides an endpoint for us to go and retrieve the public keys so that we can automate verification of that signature. If we go to take a look at the claims that are contained within that token, okay, if we go to jwt.ms, we can look at all of the various claims that are available to us. One that's important to note is the subject claim. The subject claim actually corresponds to the managed identity that is assumed by that virtual machine as it is running in Azure. Now, you also will note that we said our policy, in our policy, we said that the AZ Tools resource group has the permission to retrieve the test secret. So once we verified the signature of the token, we then parsed this string to ensure that this VM was running in the Azure Tools resource group. Once we authenticated, we applied policy and we returned a token that then the Azure Tools virtual machine, the script running on the Azure Tools virtual machine, was able to use to retrieve the secret from Conjur. One last thing I'd like to show while we're in Azure is that we can now apply this to our Azure DevOps pipelines. So I have a very simple Azure DevOps pipeline here, which is actually using that AZ Tools virtual machine in its agents pool, okay? So if I were to run this pipeline, and quite simply this pipeline, all it really does is echo out that it retrieved the secret, and it takes about 15 seconds or so for it to execute. But we can start to use these agents in these agent pools, and we can get very fine-grained about which managed identities they're running under or which user-assigned identities they are running under. And we can use those in our pipelines to get work done. Okay, so this completes in about 14 seconds, and we'll just take a quick look at the log. And we'll see that in this Azure DevOps pipeline, we use the AZ Tools VM to retrieve a secret that was authenticated using the Azure identity metadata service. Let's take a look at the log, and you can see from our output here, and I wouldn't recommend putting this output in your logs, but this is for the purposes of demonstration. There's the token that we retrieved from the metadata service. There's the token we got back to access Conjur, and here's the secret that we would need to do our work. Okay, let's go take a look at how this looks in AWS. So now if I move over to Amazon Web Services, we have a very similar process. The admin creates an allow list of those entities that have assumed an IAM role. Okay, so in Amazon, it's a little different. We're taking a look at IAM roles. Once we've created policy that allows certain IAM roles to consume credentials, the requesting party down here in step 2 retrieves a token from the AWS identity metadata service, presents that to Conjur for authentication. Conjur then verifies that header with the secure token service, which is provided by AWS. AWS secure token service comes back and says, yes, this is good. Then we present the requester with a token that they can use to retrieve secrets. Let's go take a look at this in action. So first, here's our policy. All right, so we have established 2 AWS roles. The first one that we'll go take a look at in a minute is USSE West Lambda Full. The second one is USSE West Trusted with Conjur Secret. We're going to use the Trusted with Conjur Secret one first. We're going to do that in EC2. So here I am. You know what? There we go. There we go. When we set the profiles, sorry, you're going to have to edit that part out. When we set the profiles, it moved the screen. Well, we're in the right place here, though. Okay, so, all right. So first and foremost, very simply, what we want to do is retrieve the secret from Conjur. So directly, I can just retrieve 2 secrets, a DB user and a password. Let's take a look at the code that we need to do that. This code is for a Lambda function, in which we're going to show in a minute, but quite simply, all we have to do is create this client. This client actually goes out and grabs the token from the metadata service for us. And then once we retrieve the token back from Conjur, we present that to retrieve a variable. Okay. If we wanted to take a look at the token, here's the token from the metadata service. There's kind of 2 steps here. First, we actually have to make a request to find out the role that the VM is running, has assumed and is running as, and then we use that role to construct a very simple curl statement or a very simple HTTP request to the metadata service to retrieve the token. We then present this token to Conjur. Conjur verifies it with the secure token service with AWS, and we're good to go. Let's look at this in Lambda. Here's the Lambda handler, which is very simple, right? It's about 20 lines of code, and all we're really using from this is the AWS session token, but we do have available to us in AWS Lambda environment variables that are provided to us without us having to actually set them as environment variables, an access key ID and a secret access key ID. In this case, we're going to use the AWS session token in the same workflow that we used with EC2. So let's go over to Lambda and let's execute this Lambda function. And there it is. There's the secret that we retrieved from Conjur. And one thing I want to show you here is that under permissions, we have assumed the role of USSE West Lambda Full. You remember from our policy, we said that USSE West Lambda Full has the right, it has the permission to read the variables. Okay, the variables are database username and database password. The one that we retrieved in both the Lambda function and in the EC2 example were database password and username. And we can see that from the audit logs, US SE West Lambda full and US SE West trusted with Conjur secret both fetched the database password. Now, I'd have a couple of other interesting things that I'd like to talk about here. So we talked a lot about sort of identifying these workloads and perhaps making it easier for developers to get their job done. I'd like to talk about a couple of open source projects that may help you facilitate a day in the life, right? So the first one we're going to look at is called Summon. Summon is a utility that allows us to inject secrets into the command line. So if we're doing work on the command line, a lot of times what we want to do is we want to set a username and password as an environment variable, and we will use that in various scripts. What Summon does is it plays the middleman. Summon actually will go to Conjur based on a very simple YAML configuration file and retrieve credentials that we need and set them as environment variables for us. So let's do a very quick demonstration of Summon over on AWS. So if I take a look at secrets.yaml, let's cat that instead of typing it. There we go. Okay, what I am telling Summon to do is to set the variable database username and the variable database password from these constructs that are being retrieved from Conjur, okay? If I take a look at this Summon demo script, what this does for me is I'm printing out the environment of my shell before I invoke the Summon command. And I'm grepping for DB, anything that's prefixed with DB. And we can see that database username and database password are not present. If I invoke Summon to retrieve the credentials from Conjur, I see that the environment variables DB username and DB password are set to the values that we retrieve from Conjur. Now, if I go back out and now I'm done with that Summon shell, and I ask to grep those environment variables for mine again, we can see that they are not present. So Summon is a way that we can securely store secrets that we need to do our work in a secret store such as Conjur or your Mac OS Keyring or AWS Secrets Manager. Any of those can be providers to us, and we can incorporate them into our scripting in the shell to retrieve those passwords to do the work that we need. One other construct, one other open source project that I'd like to talk about is the Secretless concept. What Secretless is it plays, again, the middleman. Secretless is a broker that will actually inject credentials into our connection requests. So in this example here, we have a user that is perhaps invoking an application in a container in Kubernetes, and we'll look at the Kubernetes example of Secretless in just a moment. But instead of making the request to connect directly to the database, we change the port. We say that we will make our request to the Secretless broker. The Secretless broker listens on that port and intercepts the request. It takes the request, it authenticates to Conjur, it injects the credentials to make the connection to the database for us, forwards on our request, and marshals back the response. What is intriguing about Secretless is that Secretless allows us to deploy applications in our containerized environments or even on virtual machines in a manner that we do not have to refactor the application to do credential management. We can connect to SSH. We can make HTTP requests as we would normally, with Secretless actually proxying and brokering the requests for us and injecting the credentials. We can allow other facilities in concert with Conjur to manage those credentials, rotate them on the target for us, and we can just go about our business of making requests for connections. Okay, let's go take a look at Secretless in action. Okay. Okay, so I have a couple of different request types here that I'm going to show you. One is an HTTP request, the other is an SSH request, and then I'm going to save the Postgres example for when we get over to our conversation about Kubernetes. So I have a sad path and a happy path for HTTP, and I have a sad path and a happy path for SSH. Let's take a look at the sad path for HTTP. All right, so I do actually have a web server running on localhost 8080. And if I attempt to curl to localhost 8080, I'm going to get denied because I am not presenting the basic, in this case, it's basic auth credentials. So what would we expect? We expect a 401, right? Because I'm not presenting the credentials. If I take a look at the happy path, okay, we're actually asking Secretless to proxy the request for us. Okay, so we're going to make the request to 8081. And Secretless is listening on 8081, and our curl request is going to be forwarded for us. And what do we expect? HTTP happy gives us a 200 A-OK, right? We take a look at SSH, very similar kind of construct. If I look at the sad path for SSH, I have an SSH server running on port 2221. However, if I try to SSH directly to that port, I am not presenting the SSH key that I need to authenticate. If I cat the happy path, you can see that my Secretless broker is listening to port 2222, and it's going to forward my request onto the SSH server with the appropriate credentials, with the appropriate SSH key injected into the request. So let's try the sad path. What do you think we're going to get? Denied. Okay. Let's take a look at the happy path. And look, we're in, right? Okay. Let's move on now to take a look at Kubernetes. So a very similar pattern to authenticating workloads in AWS and Azure applies to Kubernetes. Again, out of band, we establish a policy. That policy can be based on namespace or namespace and service account or deployment group. So we establish the policy out of band. The requesting party actually sends a certificate signing request to Conjur. Conjur then takes the certificate signing request and decodes the embedded information, the embedded identifying attributes that are in the CSR, and forwards those on to be verified by the Kubernetes Authentication API. Basically asking, hey, did you schedule this pod in this CIDR block, in this namespace, running on this service account? If the Kubernetes API comes back and said, yes, I did, then we are authenticated and we can evaluate policy. Just like in AWS and Azure, we return an access token, and that access token can be used to obtain secrets to do our work. So I'm going to show two examples of this. One is a very quick and simple, just retrieving a secret. So I'm going to shell into my application container. But before I do, I want to talk a little bit about how this works. So the application container that we're going to shell into is the Go app application container. Okay. there is a sidecar that is running next to that application container that is handling the authentication to Conjur and is retrieving the access token that allows my application running in the Go app container to retrieve credentials from Conjur. So let's just go into the shell, and the name of my executable is pass output. And there we go. We are retrieving credentials from Conjur in a Kubernetes a container running in Kubernetes. Okay. What I'd like to do now is show a secretless example, and secretless is very powerful in Kubernetes. Kubernetes it allows me to use that same Kubernetes authentication methodology to broker these requests. You see that the secretless broker is running as a sidecar next to the secretless app. The secretless app in this case really isn't running anything other than the Postgres client, which we're going to use to connect to a database. Okay, just keep in mind that because the secretless app container and the secretless broker container share localhost, we can communicate to each other across localhost, and the secretless broker can actually intercept our request to connect to the Postgres database. So let me just grab this command here so everybody doesn't have to bear with me typing it. And we're going to copy and paste that into our app. So most people would say, hey, and I like to do this at trade shows, right? So what's going to happen here? And most people are like, well, it's going to prompt you for a password. Well, in this case, it's not, because the secretless broker is going to intercept this request and inject appropriate credentials in for us, and we're in. So we can deploy applications in these application containers with minimum refactoring, because the secretless broker will intercept our requests and marshal them on to our target. I have a couple more things to talk about, and then I can give you some ideas for further investigation. So in June of 2020, CNCF actually announced that my favorite project has moved to incubator status, okay? And that is the Spiffy project. And Spiffy stands for, and you can see it there, Secure Production Identity Framework for Everyone. And what Spiffy does for us is it allows us to do this attribute-based authentication by embedding what they call SVIDs in credentials that are presented for authentication. And we can evaluate those attributes in either that are embedded in either an X509 certificate or a JWT, and evaluate those against policy. I encourage everyone to take a look at Spiffy. This is a direction that I am going further with in my own learning, and I have people in our R&D organization at CyberArk looking into Spiffy for the next generation of authentication methods. And if you want to go check out Spiffy, by the way, Spire is the reference implementation of Spiffy. They've done a great job of making that available and easily accessible for people to pull down and do experimentation with. If you're interested in Conjur, the open source project, conjur.org, and we showed you Secretless and Summon, and those are two open source projects that you should take a look at as well. I thank you for your time today. I hope this has been informational, and look forward to working more with Victor and the folks at Virtually Testing.
Thank you, Dennis, for such a great presentation and hands-on demos. For our listeners, if you have any questions, please email contact@virtuallytesting.com. Stay connected with us over LinkedIn, Twitter, and YouTube for event announcements and free training details.